As sort of introduction stated, I'm going to go through the very basic principles of forest carbon science, and then the basics of offset sort of set the baseline for terminology you'll probably hear the rest of the speakers use. And so just sort of set a baseline, and I'm happy to answer questions. And after the Arkansas meeting, I've also added a last sort of slides with some of the concerns and discussion points that were raised during that meeting to share with this group. So the reason that all of this is happening, and you heard this alluded to earlier, is that there are a ton of different legal and regulatory and then non-regulatory drivers for why companies, governments, even in some cases cities and agencies are looking to become carbon neutral or reduce their carbon footprints. Of course, there's the Intergovernmental Panel on Climate Change reports on the changes in climate and the role of increased atmospheric carbon dioxide in that. Countries around the world and independent cities have signed on to the Paris Accord for climate commitments to their nationally determined contributions. There are several states, including California and a regional network of 9 states in the Northeast that have cap and trade systems in place. We have the National Greenhouse Gas Inventory, which the NRCS folks will be very familiar with. That's the federal effort by EPA and a lot of other agencies to inventory greenhouse gas emissions and sinks in the US. And then what you probably read about day in and day out now, it's in the paper all the time, are public and private sector climate carbon reduction commitments. So that's companies like Procter & Gamble or General Mills making pledges mostly driven by their investors to drive towards reduced carbon footprints or neutrality. And that's really where a lot of what you'll hear today is about the voluntary offset market. So a lot of those private sector and publicly traded companies that are trying to reach carbon neutrality are buying offsets off of voluntary markets to accomplish those goals. And so you heard a little bit about this time period here, 2008, 2009. That was sort of when this business really started to get popular. It was the Chicago Climate Exchange. That sort of collapsed. Regulatory market never emerged, and the Chicago Climate Exchange went away, and carbon offsets were not quite as popular. But more recently, mostly driven by these sort of corporate pledges and climate accords, there have been a lot more of these voluntary carbon credits developed and sold on the market. DU has a carbon program around grasslands. I think there was some discussion today of the prairie pothole region. So one of the many mechanisms we've used in that region to fund conservation of grasslands and prairie pothole wetlands is carbon offsets. So we have been participating in this market since around the early 2000s. We don't currently have any forest carbon programs, but we have a whole lot of partners who are working on those. So right now we don't really have a dog in this fight necessarily. It's just one of the many mechanisms of conservation that we've explored. So when you think about forests in particular and forest restoration as a sink of carbon, this is just a little diagram where you have, your atmospheric pool of carbon dioxide, and live forest vegetation is drawing CO2 out of the atmosphere and into vegetation. When you account for carbon in these offset markets, you account not only for the live vegetation, you also account for the downed and dead wood on the forest floor, standing dead vegetation, soil, and then you actually also get credit for harvested wood products. So particularly durable wood products like wood that's used to build structures or houses is counted as being sequestered for a period of time in a built environment rather than in the forest itself. But those are kind of, when you're thinking about the basic carbon accounting of a forest carbon project, you're looking at live and dead vegetation, soils, and then harvested wood. And we'll talk about this a little bit later, but there is about 1 million different ways that you can deal with harvest scenarios in these projects. So at the beginning, there's a pretty high degree of flexibility for management, but you sort of then get locked in to whatever particular timber management you've selected. So how we account for greenhouse gases, CO2 and other greenhouse gases in the context of carbon markets and just in the context of carbon cycling. And these are going to be some pretty important words. There's the annual sequestration. So there's the carbon accumulation that occurs that's very long-term and or permanent. So that's either soil or peat accumulation. So carbon stays there for a long time unless it's disturbed. And the woody biomass annual growth. And when you think about the figure on the right is the sort of this little clock of forest succession and development. And when you think about carbon sequestration, it's going to be lowest in, you know, that sort of seed and sapling, that 10 to 20 year period. Growth and carbon accumulation accelerate when you're in the sort of 20 to 80 year period. And then it slows down quite a bit as a forest ages beyond that time. So that's sort of the green circle there. When you're thinking about carbon and carbon offsets, the offsets are going to be proportional to growth of the forest. So particularly with the kind of work that the CDN is doing with restoration, carbon offset potential is rather low in the first 10 to 20 years because those trees are growing small and growing, and then it really ramps up after that. Sequestration in the forest is very simply the amount of carbon that goes in versus the amount of carbon that goes out through decomposition. So soil and woody biomass minus whatever's decomposed in the forest. If we look over time, that is the stock of carbon. So the total amount integrated over time, this annual sequestration summed over all the years of the forest life. And if you look at the sort of brown circle in this development clock, carbon stocks are always increasing in a forest unless it's disturbed. So whereas annual sequestration, the accumulation peaks around that 20 to 80 year lifespan, stocks are always increasing. And so that becomes really important when you think about other types of carbon projects like avoided conversion or improved forest management. And I'll talk about those in a little more details. For this geography in particular, heard lots of discussion of flooding already. One of the really important things to account for in these bottomland hardwood forests in particular is the flux of methane. So we know wet soils produce methane, and methane is a very powerful greenhouse gas compared to CO2. So when we look at these forests overall, we not only have to look at the increase in soil and woody biomass, but also sort of subtract out the amount of methane that's released from wet forests. And that leads us to putting carbon dioxide in what I'm going to call a common currency. So we have methane, we also have other gases like nitrous oxide, and then we have carbon dioxide. And we basically use some formulas developed by IPCC scientists to convert everything into a carbon dioxide equivalent. So we're converting biomass carbon into carbon dioxide equivalents. We're converting methane into carbon dioxide equivalents. And that's how we get to sort of the common currency, and the ultimate outcome is 1 carbon offset, or 1 ton of carbon dioxide equivalents. So basically, to calculate that, we look at the carbon dioxide sequestered minus the greenhouse gases emitted in a CO2 basis. And as I said, methane, that's the second line there on the table. Methane is a big potential contributor to the story for bottomland hardwoods. And the important thing to note here is that it's about 30 to 45 times more powerful than CO2. So, oh, pardon me. So you have to sequester 30 times the CO2 to equal an equivalent methane emission, basically. So you don't need to remember that math. What you do need to remember is, unlike an upland forest, in a bottomland where we have methane, offsets are a little bit different calculation. So forests are just one of the many natural climate solutions. This is some really nice work that was done by TNC looking at the US potential for climate mitigation. 2 of the largest categories they identified are reforestation, which is what we're talking about today, and then natural forest management, which is in the parlance of carbon markets equivalent to what they would call improved forest management, or IFM. There's also a component of avoided forest conversion, which I'll talk a little bit about, but that one is becoming more and more difficult to accomplish. So we'll start with afforestation, reforestation. And many of you might recognize this graph. This was from some SEEP work that was done in the early 2000s on WRP and CRP forest restoration in the MAV. So afforestation, reforestation is basically the establishment of trees. There are a couple rules. Lands must have been degraded or have very low stocking rates and be unable to revert to forest without intervention. So those are sort of market-driven rules. And newer protocols may or may not allow for more inclusive pre-project enabling conditions. So things like interplanting and forest enhancement might be allowable, but those are much more complex projects. The simplest of these projects is really plant new trees on lands that would have, grown up in weeds or undesirable species otherwise. So as I said on the previous slide, this amount of carbon that ends up in the site is low for the first 20 years, and then it really accelerates over time. So those green, blue, and yellow parabolas are the stock of carbon over time, and then that red line is the net carbon flux. So the amount of carbon coming into the system over time. And that's what you really get credited for, is that carbon flux. And that's going to peak sort of midway through the project lifetime. Improved forest management is another type of carbon project. So this is basically a growing or mature forest where you implement some type of management practice to increase carbon stocks relative to a baseline. So baseline basically in this context means the business as usual, where timber is harvested to a level defined as common practice. So what would commonly happen in a forest in your region, depending on the protocol. So a lot of the things that can happen, and I think NCX will talk about this: deferred harvest management, extending rotation length, increasing productivity by thinning diseased or suppressed trees, reducing competition from brush or other undesirable species, improving stocking rates, or minimizing disturbances or impacts from logging. And so this is a little graph on the side of a bunch of different scenarios. So the baseline is that sort of blue line that goes through the middle. The 2 yellow lines are 2 different scenarios, one where you sort of harvest the normal amount or harvest more than the normal amount, or even completely remove the forest and convert to corn. And in those scenarios, you're losing carbon. Whereas an IFM, an improved forest management project, is that green line on the very top that sort of says where you change stocking rates or reduce the frequency of logging or extend rotation lengths to generate more carbon above one of those yellow baselines. And so these scenarios do get pretty complex to think about, but at the bottom, sort of at the basis of it, you're looking at the difference between a common logging scenario, common management scenario, and something that improves timber stocks on the property. And then the last and probably most easy to think about is avoided conversion. So as I mentioned, these projects are becoming harder to do because essentially you have to prove that the forest would have been converted without the intervention of something like an easement. And it's very difficult to prove that somebody would have converted a project, a forest into cropland in practice. Sometimes you have things like rezoning, or we've had a case where a property had already been, designs had been submitted for converting that property to a development. So there are cases in which this is possible, but it's difficult to prove. And there's a lot of scrutiny around these type of projects because of that. So basically you're preventing the conversion of privately owned forest to non-forest, something like agricultural suburban development, through a restrictive covenant, something like a conservation easement. As I mentioned, there's a really high burden of proof required to demonstrate that the proposed forest was at risk. And essentially you get credit over time for the amount of carbon that would have been released had it been deforested. And that's how you earn credits over time. So I'm going to jump into sort of some of the language around carbon projects. These are specific really to the voluntary carbon market, but a lot of them apply to like the California Air Resource Board, some of the compliance-based markets. And I want to be clear that these requirements are not only driven by these groups that are establishing registries and sort of climate minded folks. They're really driven also by the people that purchase carbon projects. So they're carbon offsets. So if projects don't meet these standards, those offsets won't sell and the landowner doesn't get their payment from those projects. So it's very important to keep these in mind when talking about projects. So the first requirement is projects be real. They have to meet a standard where they actually reduce emissions or sequester carbon from the atmosphere. And they're supposed to avoid something called leakage. And leakage refers to CO2 emissions that are shifted to other areas as a result of a forest carbon project. The simplest way to think about leakage is if I restore 1 million acres in the Mississippi Alluvial Valley of forest, then is are growers or cities just going to deforest 1 million acres elsewhere to make up for that? And so leakage is sort of out of the control, sometimes the developer, but there's sort of math that you go through to estimate what the risk of leakage. But we definitely don't want to do projects where we just shift land use elsewhere. We want to be additive. And that's what sort of the requirement of being a real project that meets these standards for reducing emissions and avoiding leakage is. We want projects to be additional. Additionality means that the carbon sequestered in a forest project would not have happened without the project. And so there's two, I'm going to describe them very simply, but there's a lot of complexity behind these. There's two basic tests that are often applied. There's the regulatory surplus test. So you have to be able to prove that the activity wasn't legally mandated. So for instance, you could not generate carbon credits on a 404 wetland mitigation that was legally mandated. There's also the common practice standard. So if it is common practice in a region, and this is defined mathematically in a bunch of different ways, so I'm not going to go into that, but basically what's common around you. If you're doing reforestation, this is an extreme example, but if you're doing a reforestation on your property and 99% of the landowners in your geography are also doing reforestation, you don't qualify for carbon markets because reforestation is a common practice. Everyone's doing it. And so it's assumed that it's not additional. And we could argue about what that means, but those are, in a very basic sense, the kind of tests that are applied to prove that a project is adding carbon sequestration that wouldn't have happened if carbon finance wasn't involved. Projects have to be verifiable. So the offset project has to be monitored regularly by a qualified and independent third party. You'll hear a lot of, I think you'll hear from a consulting forester. Those folks are often involved in timber cruises to verify these assets. You'll also hear today from some folks that are developing ways of doing that using remote sensing. But at the end of the day, you have to be able to count the change in carbon through models or measurements. And then those have to be independently verified by a third party. So there's a series of consulting firms that look at the calculations and look at the activities on the ground and review contracts and basically say, yep, this is a valid and verifiable project. And then there's two more here. Permanent emission reductions cannot be temporary and reversible. So for avoided conversion projects, the use of conservation easements contributes to this permanence. You'll hear today a little bit of discussion, I think, about other ways of looking at permanence or looking at non-permanence. But generally, these have to be long-term projects under the way the current methodologies work, and there may be changes to those. But for now, these have to be very long-term commitments by a landowner, usually 40 to 100 years, which is prohibitive for some landowners, a lot of landowners. In the case that a project is not permanent, in case there's a intentional reversal or an unintentional reversal. So intentional reversal would be you cut down the forest even though you're still under contract. An unintentional reversal would be a forest fire or a massive flood that killed off a lot of your saplings. In those cases, you set aside credits in what's called the buffer pool. In those credits, you can draw on those credits in case there's, some amount of your trees die and you release some amount of carbon. You always have this buffer pool of unsold credits that can be used to make up for that. And we've had a very real experience with that recently. One of our carbon projects, 70-something% of it burned due to the droughts out west. And so that's, it's been comforting to our landowner there because they don't have to, they're not legally responsible for an act of God. They don't have to pay back the money they've made on carbon because there was a fire that was completely out of their control. And then finally, these carbon credits have to be enforceable. So credit ownership has to be clearly established and you have to avoid double counting. Basically what that means is you have to have some sort of legal description of ownership, and carbon rights have to be established through contracts and clearly conveyed between entities. And avoiding double counting essentially means you can't sell credits from the same activity on the same parcel of land on two different people. You can only sell them one time. They can only be accounted for one time. You're gonna hear from a lot of these folks today, but there's a bunch of different roles in carbon projects. There's a project sponsor or project proponent. And that might be an entity like TNC or Ducks Unlimited, or one of the registries you'll hear from today, or one of the developers you'll hear from today, where you coordinate with a developer, a landowner, consulting forester, land trust. You coordinate all the different pieces of the project. The carbon project developer plays a very important role in this. This is the person or people who develop the carbon credit models based on proposed activities. And they tend to be, technical experts in modeling forest carbon and understand the registry's protocols. So these project developers are really the ones that are doing all the math to estimate credits and submit documentation and understand the registries. We all know who the landowner is. The landowner is really the person who's going to decide whether they want to implement the project and enter into legal documentation for things like restrictive covenants and management contracts, and convey carbon rights and work out a deal for sharing of revenue with project sponsors and project developers. I mentioned this before, but verifiers are the third parties that are accredited by American National Standards Institute to conduct reviews of projects and verify them in order to issue and sell carbon offsets. And then the registries themselves are the entities that kind of regulate and keep the, you can think of them sort of as the bank of carbon credits. They review paperwork, they establish accounts with carbon credits in them, and then when those carbon credits are purchased, they're serialized and they're retired. And so the registries are really the ones that keep up with inventories for projects. Some projects choose to work with brokers or marketing firms to help sell their carbon credits. It's sort of a choice, but and then there's consulting foresters. I think most of us know what those folks are. They play a really important role in forest inventory that sort of establishes the data required to model carbon stocks. And then there's consumers, the entities that purchase carbon credits. In some cases, there's a large group of landowners in the MAV right now whose carbon credits are getting sold into California Air Resource Board market, the cap and trade market in California. There's also tons of private companies that are purchasing these. If you've ever purchased an airplane ticket and they've allowed you to offset your CO2 emissions, there's a whole bunch of different folks that consume these credits, but basically they purchase them from the registry and the registry retires them and the proceeds go. Usually they're split between the developer, the project proponent, and the landowner. So this is kind of my slide that I added after we had the meeting in Arkansas about open questions that have come up. So one that we work on a lot is the legal landscape. It's really hard to find legal counsel around carbon credits for landowners. We fielded a whole lot of calls, and it's very hard to find somebody who can accurately give counsel, because there's carbon rights aren't necessarily like mineral rights or other rights that are conveyed with land. They're a little bit nebulous. So there's a lot of work in this space, but particularly in this geography, it's hard to find, somebody independent to advise landowners. There's a huge variety of programs available. I think you'll hear from 3 or 4 today. There are probably 20 operating in the MAV alone. We're trying to keep track of them for the benefit of our program participants and members. There's huge variety. It can be a little bit of a confusing space, and it's difficult to find a good opinion on what's right for a landowner. One of the ones that sort of keeps me up at night working for Ducks Unlimited is the change in practices required and their compatibility with desired forest conditions for wildlife, or maybe lack of compatibility. Certain projects like improved forest management you can kind of get locked into a certain set of practices, and what that does for things like some of the thinning we would like to see to improve habitat conditions, they may not be compatible with maximizing carbon storage. Some of the things we'd like to see for wildlife. That doesn't necessarily mean carbon markets are bad for wildlife. It just means there's a lot of work to be done on compatibility. You may not be able to maximize carbon and wildlife simultaneously. There may be some trade-offs there, and that just means you don't make quite as much money from carbon, but it is something to consider here. And the other thing is water management. Currently, active water management is not allowable under the registry. So things like GTRs or anything where you have boards you're pulling to actively manage water levels, it's currently not allowed under many protocols. That's something we've been talking to registries about doing research to change. The flexibility of contracts, there's a huge range. You'll hear NCX talk, their contract is very, very flexible, ranging all the way from some contracts that lock landowners into a certain set of practices for 40 years of practices and 100 years of verification. As I mentioned, methane in bottomland hardwood forests is a huge open question. Mississippi State has a really nice project that just started on CRP and WRE sites, looking into this beyond what's already been done. We find that some landowners lack understanding or perception of benefits of reforestation to wildlife. And I think that's something this network certainly has a lot of input on. And then there's a challenging market landscape. There's some questions about compatibility of these markets with USDA programs or other federal programs like the North American Wetland Conservation Act funding, NACA. And then there's a little bit of shifting sands with what the government gets to count versus what can go on in private markets. So these are just a lot of the things that are still getting figured out in this geography. And I think I probably burned through my time, but I'm happy to answer any questions if I can. And I apologize, I would really like to be here for the later part, but can't make it work.
Did I do that? I think she's still there.
I'm here.
Okay. I think when you ended the slide, it freaked me out. I don't know, it freaked everybody else out.
Oh
no. Okay. Well, thank you very much, Dr. Herbert. Does anybody have any questions? Don't be hesitant to ask just because it's on Zoom.
And you're welcome to reach out, but Steve has my email. You're welcome to reach out by email with questions, and hope you'll have a good rest of the day.
Yeah, I think we have a question.
Yeah, I was actually just going to ask you about the email.
Okay.
I don't know what your email address is, but I was wondering, you had mentioned like the offsets with methane versus CO2. So if you have a large area that's a swampy, decaying area of bottomland, so you're kind of generating the methane there, and you're also trying to sequester carbon, do you need to have a larger tract of forest to offset that swampland that you have?
Could you hear that?
I could. That's a good question. It really is, and this is Austin Himes at Mississippi State has a big project that's looking at this right now. It's really the balance between carbon sequestration and methane emissions. And that generally doesn't change too much. It's sort of, acre by acre. 1 acre emits this much methane, 1 acre sequesters this much carbon. It is variable with topography and productivity. but there's no simple answer other than, working with academics or project developers to model that scenario. And it is, at least historically in projects that have occurred in the MAV research projects, forest growth does offset methane emissions. It's just something to be pretty aware of, that bottomland forests are not as easy in this context as upland forests because of that question.
Yeah, that's interesting that you asked that question, because just recently we got a request from a partner, the joint venture did, and it was, I wish I had looked at the paper before the meeting, but they forwarded a paper that was recently put out, which you obviously shaking your head, you're familiar with, that evidently indicated the methane emission was greater than the carbon offset or something. I have not read the paper, but we basically, your question was asked of the joint venture because someone in the Washington office said, hey, we're concerned that WRE is actually not offsetting carbon. So.
Yeah, and that particular paper was specific to the tropics, which tends to have more methane emissions. I mean, the other thing I'll tell you is that there's a bunch of papers now that say that upland forests are emitting methane, and that, so it's, like I said, I think there's new work going on out of Mississippi State around this in this geography that I think will be clarifying, but it is, we're just always learning something new about the way these processes interact. But that particular paper that's caused a lot of buzz is really centered on the tropics. And I don't know, maybe it's starting to feel pretty tropical here, but yeah, it's a significant question right now.